All right, guys, welcome to lesson 3.4. We're going to talk about these things called piecewise functions today. Kind of jumping all over the place, it seems. In lesson 1, we talked about absolute value functions and how to solve them. Lesson 2, we talked about transformations. And then lesson 3, we talked about graphing absolute value functions. But I did transformations before the graphing of absolute value functions because they're kind of connected. Well, now we're going to move on to piecewise functions, and you'll see why later on. The piecewise functions actually connected to absolute value functions also in an interesting way. So let's go ahead and talk about what piecewise functions are. So you're going to learn what it is, and then you're going to learn how to actually rewrite absolute value functions as piecewise functions, because that's what they really are. Okay, an absolute value function is actually a type of piecewise function. So why do we learn this stuff? For some mathematical computations, especially in calculus, which once again, the purpose of this class is to get you ready for it, it's helpful to think of absolute value functions, not as absolute value functions, but as piecewise functions. So what we're going to do is we're going to learn what a piecewise function is and how to rewrite an absolute value function as a piecewise function. Okay, that's our goal. So to begin, I found this little video on YouTube, which I thought we would check out. So let's see if this will play for us. Here we go. Waiting. I don't know if you guys will be able to hear the sound or not, but it's not a big deal. You don't need to. All right. We can stop there. So that scenario creates for us an opportunity to kind of study it from the perspective of a piecewise function. So if I create a vertical axis here that represents the height of the rocket, and I let the horizontal axis represent the time, then the graph might look like this. Now, you'll notice that it looks like this graph has three pieces to it, right? There's this piece, and then there's this piece, and then there is this piece, right? So there's three parts to this, and that's because during this rocket's little journey through the air, it kind of went through three different phases. So what was happening in this first phase here that I've got highlighted in yellow? Well, as you guys can see, the height of the rocket is increasing very quickly over time. It's jumping up really fast. And so that's because that's whenever the rocket's engine is working. That's whenever the flame is busting out of the back, causing it to fly up in the air. So we'll say here is where the engine is active. But something happens right here at this point. What happens at this point? At this point, the engine turns off. It's no longer shooting up in the air anymore. It stopped shooting up because of the engine. But it did kind of keep going up a little bit after that, but then the height started to decrease. The reason for that is because the engine ran out here, the fuel of the rocket ran out, and after that it flew up a little bit higher just because it had some momentum. But then gravity starts to pull it back down. So this little phase right here is what we would call free fall. The gravity is just pulling on it, right? And here's where the engine turns off. Okay? But something else happens here now on the blue line. What's going on there? it was falling, and it actually started falling pretty quickly because of gravity, but all of a sudden something happened right here at this point that caused it to fall more slowly. What was that? Well, that was the parachute. Okay? So, now here's the thing. The yellow line here, that's a linear function. It probably looks something like a y equals mx plus b, right? That's the yellow line that we see there. The green one there, if you guys reach back into your memory banks from Algebra 2, that kind of looks like a parabola, doesn't it? Parabolas those are quadratics. Now if you don't remember this stuff, that's okay, but the green one looks like a quadratic to me. It's like a parabola. And then the blue one looks like another linear function, so it's another mx plus b, but it seems to have a negative slope, so I'm going to put a negative there. If we put all three of those pieces together and call that y, now I've got what's called a piecewise function. It's one function, but really what it is it's one function put together. It's really just three little functions put together to make one big one, okay? Maybe the rocket started here at time 0, and then the engine stopped after like maybe 2 seconds, we'll say, right? So from t equals 0 to t equals 2, we have this mx plus b, this yellow line. But after that, for like another like maybe 3 seconds or so until t equals 5, now we're in a free fall mode, and that's where it's quadratic. So from the time of 2 seconds up to the time of 5 seconds, we have a quadratic, a free fall mode. After that, the parachute comes out. So from 5 seconds all the way up to like maybe we'll say 10 seconds. So for t values between 5 and 10, we have the negative linear function there. Okay, so we have one function, which we're going to call y. And what y is it's really just three other functions put together at three different points in time. Okay, and that's what we call a piecewise function. Piecewise functions are really useful for modeling real life scenarios because in real life, kind of like on this rocket, different things are happening at different times, and we want to see the whole thing all at once. So that's a piecewise function. Now, before we begin, I want to review inequalities for you guys. This symbol here means that x is greater than a. Now, technically, if x is greater than a, you could say that a is less than x, so it kind of means the same thing. But the way we read it is from left to right. X is greater than a. And this one down here means x is less than a. And if you ever get confused on which one is which, think of this as Pac-Man. And Pac-Man always wants to eat the bigger numbers. So in this case, x is bigger than a. And in this case, since Pac-Man's not eating the x, he's eating the a, that would mean that x is less than a. Okay, so that's a good way to remember it if you forget what it means. So here's the anatomy of a piecewise function. It says don't write, but you can ignore that. I guess if you guys are taking notes by hand, you wouldn't need to write this if you don't want to. But if you are printing out the notes, then you have a bonus. You have this in your notes. For those of you guys who are taking notes by hand, don't worry about it. You're going to get a chance to write plenty of things like this later on. Okay, it'll just take a lot of time to write it. I wouldn't encourage that right now. So here's what I wanted to point you guys out to. We have this function here that I'm going to call g. And as you can see, g has three different parts to it. That part, and that part. It seems that g is equal to negative x plus 1 anytime x is less than 2. So if x is less than 2, then g is going to be negative x plus 1. So here's where x is negative 2 on my graph. And anything less than that, meaning to the left, is this line here. This line here is the linear function negative x plus 1. It's a straight line function. It's a linear function. All right? The next one, let's jump down to the bottom here. Here's another linear function, another straight line. But this time it says that g of x is x minus 3 if x is greater than or equal to 4. So here's the dot where x equals 4. And anything greater than that, meaning to the right, is this line. And as you can see, that's a straight line again. And that's this one, x minus 3. Now in the middle here, we have another piece, the square root function. You guys probably don't remember what square root functions look like. But anytime x is between -2 and 4, we have this square root function. So here's -2. Now that's up here. And then here's 4. It's also here, but we could say it's here also. But anywhere between these two purple dots is this line, which is the absolute value function. I'm sorry, the square root function. And that's what square root functions look like. They kind of look like a half a parabola on its side. What's interesting about this particular function is you'll notice that on the interval from -2 to -1 in here, in this region, the graph doesn't exist. There is nothing for g. So we would say that if somebody asked us to plug in g of -1.5, that would mean there's no solution because there's no point in between -2 and -1. That's a blank spot in our graph. Okay? But anyway, this is a piecewise function. So basically what these are these are the equations of each of the lines that are on the graph. And this is what we call the intervals. And it tells us on what interval each line exists. So this line exists on the interval of x less than -2. So that's this one. Anything to the left of x equals -2. This one, x minus 3, exists for anything where x is greater than 4. So from 4 and to the right. And this one is the middle function between 2 and -4, which is this one here. So that's the anatomy of a piecewise function. It tells you what the equations of each piece are and on what interval each piece exists. All right. Now, I also put here don't write. So once again, if you're taking notes by hand, you don't have to worry about writing this page. You're going to get plenty of opportunities to have useful information later. But if you printed it, you've got the bonus. You've got it right in front of you, so that's good. So here's the thing. Absolute value functions are piecewise functions. In Unit 1, we learned about these things called linear functions, right? Y equals mx plus b. And what they are, they're just straight lines. Like if I gave you this, y equals mx plus b, if you graphed it, you get a straight line, right? Well, basically what an absolute value function is it's just two straight lines put together. There's one straight line, and there's another one. Okay? So for anything to the left of 0, oops, wrong color. For anything to the left of 0, over here, we have a linear function with a negative slope. And for anything to the right of 0, over here, in other words, anything where x is greater than 0, we have the same line, but the slope is positive this time. So basically, what an absolute value function is even though we can write it as one single function, another way you can think of it is as two straight lines that are hooked together at a common point. Okay, now, why are we doing this? Well, like I said, in calculus, we do not like absolute value functions. They don't behave well in calculus. Anytime we're trying to do calculus on an absolute value function, it causes problems. But if we split it up into its pieces and treat each piece separately, in other words, if we think of it as a piecewise function, then we can do lots of good things in calculus with these. So that's why we are making the connection for you guys today between absolute values and piecewise functions. So basically, absolute value functions are piecewise functions. And today, our goal is going to be to give you guys an absolute value function like this one, and then your job is going to be to change it into a piecewise function. So what I want you guys to do right now is I'd like you to pause the video if you're writing by hand and copy this slide. If you've printed the notes out, then you're cool. You can just kind of follow along with us now because we're done. But let's go ahead and talk about it. So just like I told you before on the last slide, an absolute value function is like having two linear functions that are just connected together at a common point. Okay? The only difference between the two pieces is that they have opposite slopes. So for the one on the right, slope is negative. This line has a negative slope, so notice there's a negative in front of it. And for the one on the, I think I said that backwards, that's the one on the left, right? So the one on the left has a negative slope, so that one has a negative. And for the one on the right, that one has a positive slope. You have lost that cool color that I had. There it is. All right. So for the one on the right, it has a positive slope. So there's that one. So just so you guys know, this means that x is less than. So when x is less than, that means it's to the left of x. And whenever x is greater than, that means that x is to the right. Okay? So let's chat about it a little bit. Okay. So as you guys know from our lesson last time, the h and the k represent the vertex. Now, when you do your intervals for each piece, remember on a piecewise function, we're thinking of it as two pieces put together there. The dividing point is the vertex. And that vertex there is hk. Now, intervals are always in terms of x. So we really don't care about the k when we talk about the breaking point here. We really just look at the h. So the top piece is going to be anywhere where x is less than or equal to h, and that means the left side. That's the left side of our graph because that's where x is going to be less than or equal to h. So we start at h and we go to the left where x is less than h. And then for all x greater than h, that's anything on the right side of the graph. Now, as I pointed out before, with these absolute value functions, these two lines are actually identical. The only difference is that their slopes are opposite. So for the one to the left, it's going to have an opposite slope from the one on the right. And how it's always going to work is that the one that's on the left is going to have a slope that is opposite from the original. Whatever the original slope was, to the left half of that graph is going to have an opposite slope. And to the right, it will have a positive slope. Or not a positive, but it'll have the same slope as the original. Okay? And that's pretty much it. Okay? So let's kind of review the key points here. What goes here? So let me actually do a few more things here. Let me get my whiteout going and get rid of the H. Your setup is always going to look like this. Okay? You're always going to have a function here and a function here, and then you're going to have an x less than or equal to here and an x greater than here. Now, you're going to take your absolute value function here at the top, and you're going to write it twice. Once on the top and once on the bottom. For the one on the top, though, you're going to make the a have an opposite sign from what it originally had. And for the one on the top, the h tells you what goes here. So for the one on the top, that's less than or equal to. And notice that this one's equal to and this one's not. Why is that? Well, the point is that as you guys look at this graph, oops, didn't want to erase stuff. As you guys look at the graph, do you see any holes in this graph? I don't. It looks nice and complete. There's no gaps. So the function exists everywhere. It even exists right here at the tip where it splits. So h is an x value that actually exists on this graph, and therefore it has to be somewhere on this function. So somewhere x has to be able to equal h, okay, since it does exist on the graph. You could put it here or you could put it here, and it doesn't matter where you put it because they're both going to give you the same answer. But technically, when you do piecewise functions, you shouldn't write the equal to twice in the same spot, because otherwise a mathematician might not know which piece the h goes with. Does it go with the top or bottom? Now, for absolute value functions, it doesn't matter, but for other types of piecewise functions, like the one we looked at earlier, where was it? Right here. This one, for instance, it would matter. Notice right here it says x is less than 2. This one says x is greater than or equal to 2, though, right? Well, that's because, well, that's a bad example. Use a different one. This one says x is less than 4. This one says x is greater than or equal to 4. Well, this is where x can actually equal 4. For the other piece, even though we have the dot of 4 there, it can't actually equal. So that for this one, it's an open dot for the square root function. But for the linear function, it actually equals 4. So we'll get into that a little bit more on a later date. But for now, if that's confusing to you, don't worry. We'll clarify it more in another lesson. But for now, what I want you guys to know is this setup, okay? The top one, the slope will be opposite, and the number that goes here is the h value of your vertex, okay? So let's go ahead and we'll do one really quick. Rewrite the absolute value function as a piecewise function, okay? So how do we do that? All right, we're going to say y equals, and I'm going to write this whole thing twice. But when I do, I'm going to get rid of the absolute value bars. No more absolute value bars. It's going to be parentheses now instead. And the one on the top is going to be an opposite sign than it is up here. So instead of a positive 3, I'm going to put a negative 3 there. Then over here, this is for everything where x is less than or equal to, which represents the left half of my graph. And this bottom one is where everything where x is greater than, and that's the right half of my graph. But what number goes here? Well, as we said before, that's the h value. In this case, the h, and you always go with the opposite sign like usual, the h value is the 3. So you can leave your answer like this if you want to, or you can simplify it. So I can distribute that negative 3 and get negative 3x plus 9 here and 3x minus 9 here, if you want to distribute. So this would be the most simplified answer right there. Okay. So these two functions here are exactly the same function. Let me clean this up a little bit. So if you guys were to graph this function using what we learned last class, and then if you were to graph both of these straight lines using what we learned in Unit 1, but making sure that they stay only within their intervals, you would find that these are the same exact picture. They look exactly the same. I'm just changing it from being an absolute value function into a piecewise function. And why do we do that? Well, because I told you it works better in calculus. But let's go ahead and do another one here. So let's go ahead and take a look at this one. So what do I do first if I want to rewrite this as a piecewise function? Well, the first thing I'm going to do is I put y equals, and I want you guys to fill in these two spots. So pause the video and fill in those two spots. What you guys should have put in there was you should have put the same thing, but with parentheses twice. But with one little twist. The one on the top needs to have an opposite sign in the front. So instead of this being a negative 2, it's going to be a positive 2 now. Always change the sign of the one on the top. Okay? Now I want you guys to fill in these two blanks over here. Pause the video and give it a shot. Here's what you guys should have put. X is less than or equal to 4, and x is greater than 4. Okay? Now, you can simplify these. So what I'd like you guys to do now is I'd like you to simplify both of these equations and write your final answer. So go ahead and pause the video, and when you unpause it, you'll see the solution. So if you distribute your 2 and add the 1, you should have gotten on the top 2x minus 7, and on the bottom negative 2x plus 9. And there's your final answer. And I want to reiterate that this function is a piecewise function, but it's actually the same exact thing as this function, which was an absolute value function. All right, let's go ahead and have you guys do the student practice here all on your own. So pause the video, do the whole thing from beginning to end, and check your work. When you unpause the video, you will see the solution. So on the top, we have 3x plus 4. We changed the 3 from a negative into a positive. And then for the bottom, we have negative 3x plus 4. That one stays the same. The top is where x is less than or equal to. And what is it less than or equal to? It's less than or equal to 0 because that's the h value. There's no number in here with the x. And when there's no number with the x, that means the h value is 0, which we learned a couple of lessons ago, or maybe it was last lesson. And then there's your final answer. Okay. All right, so let's go ahead and move on to one more thing before we finally call it quits. But before we do, I just want to prove the point that I've been saying to you guys. So bear with me here for a second. I'm going to take you to a graph, and I'm going to graph the original problem. And then I'm going to graph this problem. And I want you guys to see that they're actually the same exact thing. So I'm on a really cool website called desmos.com. If you guys haven't ever checked it out, feel free to. It's very helpful for graphing. But anyway, I'm going to start by typing the very beginning equation. We had y equals 3, and then absolute value of x. So here's that graph right there. So that's the original function. Now I'm going to graph the other function, which was a piecewise function. Now when I do this, I'm going to do it in pieces. So the first piece that we got was negative 3x plus 4. Now that's this blue line. You see how it's perfectly matching up to the left side of the graph? And the way that we can limit it, remember it said that that piece was only for all x that was less than or equal to 0. So now that I put that on there, it stops the blue line from continuing to go down this way, and it stops it when x equals 0. And now I'll type in the rest of the half of the piecewise function, which was 3x plus 4. And that green line represents the line 3x plus 4, but we want to make it stop at x equals 0 there. So that one was on the interval from x is greater than 0. And as you can see there, by putting the blue line and the green line together, those two linear functions, but stopping them each at 0 where they touch, they are the same thing as that original red absolute value function. Okay? So before we call it a day, I want to show you guys how to graph one more type of problem. Let's continue our lesson. And it's something that we've seen a couple of times. Let's go ahead and do example 2. All right, now, once again, we're faced with the problem of what happens when you have a number in front of your x with these absolute value bars. Well, the answer is you're going to do the same thing that we've been doing, okay? So what have we been doing with those? We've been factoring them out, right? So the first thing we're going to do is we're going to put negative 3 out. So if I divide this by negative 3, I'm left with x. And if I divide that by negative 3, we end up with a weird number, like a decimal, 4 divided by 3. Since we're dividing negative 4 by negative 3, it becomes positive. When you divide a negative by a negative, it becomes positive. And then 4 divided by 3, I'm not going to write it as a decimal. I'm just going to write it as a fraction. 4 over 3 is 4 divided by 3. So there's that. Okay. The next thing that we did after we divided out the 3 was we separated that negative 3 from the other one in two separate absolute value things. We take the absolute value of negative 3, which is 3, and we multiply it times the front. So now we have negative 9 absolute value x plus 4 over 3 minus 3. So that's the first thing you do. After you've got that done, you're ready to rewrite this as a piecewise function. Because after you've done that, there's really no difference anymore. It's literally the same thing. So The top is going to be this same expression, but instead of absolute value bars, it's going to have parentheses, and it will have an opposite sign from the front. So it's going to be positive 9, parentheses, x plus 4/3 minus 3. And then the bottom one is going to be the same sign as it originally was, a negative 9. And the top piece is for all x that are less than negative 4/3. Remember to change the sign of the h value. And the bottom is for all x greater than negative 4/3. Okay? And there's that. And we could simplify it if we want to, but that's kind of unnecessary at this point. I just wanted to make sure you guys knew that, once again, whenever you have this situation where you have a number multiplying the x, before you do anything with it, you're going to want to factor that number out. Okay? So, all that being said, let's let you guys practice one of those real quick. You have a leading number that you'll need to factor out, and then after that you can write the final answer. So go ahead and pause the video, and when you're done, you will see the solution. Now, I did not simplify mine once again. I just left it like this, but here's the solution. Your final answer would have looked something like this if you left it unsimplified like I did. If you simplified it, it would be 4x plus 9 and negative 4x plus, or maybe negative 4x minus 7, I think. But anyway, so the first thing we're going to do is factor out the 2, which would leave you with x plus 2 in the parentheses. Then you would take the absolute value of the negative 2 and multiply it by this negative 2, which would give you negative 4. And then we have this expression. So we know that when we rewrite this as a piecewise function, we rewrite this equation twice, one here and one here. We use parentheses instead of absolute value bars, and the top one has an opposite sign from the original. So the number that goes over here is the h value, but it's the opposite sign of it, right? So it's going to be negative 2, and I forgot to put the negative on this. There you go. So there's our final answer, and that does it. So now you guys know how to turn absolute value functions into piecewise functions. And now you guys can sleep better at night, right? I mean, this is what you've been dreaming of. Don't you guys remember, like, when you were like 5 years old, you're like, Mommy, when will I be able to turn an absolute value function into a piecewise? And today's the day. So you guys, I want you to go out tonight, and I want you to like celebrate. Go tell your parents to take you out because you finally learned how to change absolute value function into a piecewise function. So proud of you guys. See you next time.